I'm Lisa Williams with Old Line Environmental, and we are a contractor that does land applied biosolids in the state. We follow the regulations that Allison went over, so some of my stuff is going to cover a little bit of the same things that she did, just as a brief overview. But I'm going to cover a little bit more about the wastewater treatment process, as well as sort of the land application process, how it works, what it looks like, what you have to do as a nutrient management consultant, writing a biosolids plan and figuring out application rates. So a lot of my stuff's going to kind of be more of the actual operation and the management of using biosolids in the field. But before I get too far, I wanted to kind of explain sort of the wastewater plant. I heard there was a lot of questions kind of about trash or things like that. So as I go through the process, we can talk about how it works at the plant and why you really shouldn't see anything like that. And with today's technology, it's pretty unusual to see something like that come out of a wastewater plant. Anyway, I like this picture just so you all can kind of get an idea, but this was a pasture field that was applied with biosolids, and one of the big questions we always get is, does it run off? Well, you can see those squares in the middle. They obviously got the nutrients and the biosolids, and they were buffered from a property line or a ditch running down. And you're not seeing little thingies coming off of that that's green. So it's kind of sticky stuff. It stays in place. It adheres to the product, the soil, the grass, whatever product. So it is kind of interesting. But you know, there's a lot of questions about biosolids use. So anyway, so what are the biosolids? Of course, the state still says sewage sludge. All of us in the industry have moved to the term biosolids since it sounds so much nicer than sewage sludge. And again, what it really is the treated biosolids, you know, coming from the plant. So the solids in the wastewater treatment plant are all sort of captured and then taken to one place in the treatment plant and then treated. And then what we call that is what's really available for beneficial use. And for us, that's the biosolids term. So really, it's the organic matter that's coming through the treatment plant, as well as the treatment plant, just so you know, is really a living process. It kind of mimics how a stream cleans the water, but they've just kind of expanded it and enhanced it so it works faster and uses bigger volumes. But organisms and bacteria are what really clean at a wastewater plant. So a lot of the organic matter is sort of recycled organisms that are working at the process as well. So again, Allison passed around, I guess, the DC Water Class A product. They've now gone to a Class A technology, which is a thermophilic digestion process, and they make a Class A biosolids. That was their Bloom, their trademark going around, and that is a treated biosolids that can be sold and put on your, you know, at Home Depot or whatever, and then put on your garden if you want. They've basically gone to that next technology. So as Allison explained, there's a Class A, which can be used across the board for gardens and home use, and then there's Class B that needs a site-specific permit that has to be used sort of in accordance with, you know, all the site restrictions and testing and so forth that you talked about. So Blue Plains treats 300 million gallons of wastewater a day. It's one of the largest plants in the country, and they basically have, they cover sort of southern Maryland areas, northern Virginia, and the district. So it's a huge plant. So talking about wastewater treatment plant. So basically what happens, stuff gets flushed down the toilet, comes to the plant. So literally what happens in a wastewater plant is there's a couple different stages, and literally what comes through the front of the plant, I didn't even put this on here, but just because you had some questions, there are huge bar screens and things that capture the large pieces of stuff that come. So boards and plastic and rags, and you can't imagine the things that come down the wastewater treatment plant. So that gets caught in the front end and literally gets put into dumpsters and hauled out as grit. I mean, those are normally large volume, large plastics and rags and things. But the next process is really a physical process. So all the wastewater then comes in and it goes to what they call primary tanks. And in that primary tank, literally it's just physical separation. The heavy stuff falls out. Solids kind of fall down, sands and grits and things fall to the bottom, and the water's on the top and the water goes off. Solids come out the bottom, that's the darker color, kind of goes across. And throughout the whole treatment process, all the solids from the different processes are collected, taken to a tank or a storage area, and that's what then gets treated for the biosolids program. So as different stages of the plant. The next step is really where the heart of the plant is. It's called the secondary treatment. And the secondary treatment is really biological treatment that I talked about. So this is where they sort of feed the bugs, as they say. They make sure they bring in, you know, enough raw sewage so there's food in there for them to eat. They try to maintain temperatures depending on the time of the year. They aerate it so there's enough oxygen in there. They want the bugs to be worked. So they're literally trying to manufacture a stream situation, enhancing it so that the organisms can eat more. They die more, like more microorganisms are generated, and it's just an ongoing system. So the solids that fall out of the secondary treatment at that point are some of the organic matter still in the raw sewage, but it's also a lot of the microorganism bodies that have just sort of gone through a life cycle and then it passed to the bottom. Advanced treatment, which is really where we're headed in most wastewater treatment plants anymore today, is where we're talking about moving more of the nutrients. So the nitrogen, the phosphorus. And a lot of this is done, some is biological, but most of it is a chemical process. So they're adding some kind of chemical, an iron or ferric, to tie up and precipitate phosphorus. They're doing sort of an anoxic and an aerated zone to do the nitrogen cycle and literally remove nitrogen through nitrogen gas. So as Allison said, at the end of the treatment plant, the more treating the clean water to go out to the bay and the rivers, the nutrients are all ending up in the solids. So all the way through the process, all the solids are captured. Most plants anymore, I put dewatering there at the end, are managing basically all the solids are generated and treated in one process, and then they're typically dewatered, meaning they squeeze some of the water out with a belt press or centrifuge, just because they don't want to pay a contractor like me to haul water. They won't haul more solids. So that's kind of the treatment plant in a nutshell, but it's really kind of a cool process. I mean, when you go from the beginning to the end and see what the treatment plant does, it's, again, this is a an public health process. We have to have wastewater treatment, or our communities and environments, we will not survive. So this has to happen, or we will not be able to live in cities and communities. So just keep this as a necessary evil for kind of living in the environment we are today. I'll go over this real quick because Allison touched on a lot of these. But again, for Class B, again, that's treatment biosolids, the biosolids at the plant that are treated to one phase that basically can go out in a permit where you need a site permit for the site. So you still need to do all those restrictions, buffer from the neighbor and the well, do the package that included all the maps and so forth. So one of the three most common processes for Class B, and I think Allison had a couple more, but anaerobic digestion, and lime stabilization. So literally these three processes are what most of the treatment plants are using for their Class B programs. Again, if we go to A, she touched on this again too, this is a quick reference, but A means they treated it even further. So they've done another step, they have to meet the metals or more stringent standards that they have to meet, and the process for pathogen reduction. So they have to test pathogens, and the metals are higher, and they have to meet this particular process, which is a further process. So the composting to the next level, thermal drying, where you're drying to a high temperature, pasteurization, which is a certain time and temperature thing. So all these are sort of the next level. And if you do this process, then your material comes out, you get a sort of a general distribution permit, and you can sell it, like we said, to Home Depot and other folks. And again, why do we do this? Wastewater treatment, like I said, is a necessary evil. We've got biosolids coming out of treatment plants every single day. They are really a very good nutrient source. It is high in organic matter. The goal, though, is we've got to protect public health. We've got very good stringent federal and state rules. We also want to make sure we're protecting, sort of surface water and groundwater. And the treatment plants need a reliable end source. We can't sort of change the rules on them every day. They need to know when they clean the water, the solids have to go, or the treatment plant doesn't work. If the solids aren't removed from that treatment plant regularly, the treatment plant can't function. So it has to kind of come out. And again, what are the benefits? Again, we've talked about the nutrients. Again, biosolids are sort of an unbalanced fertilizer, similar to some of the manures. It's high in nitrogen, does have a fair amount of phosphorus, doesn't have any potash. Does have a lot of micronutrients, depending on what you're looking for. It does have, a lot, like you said, a lot of organic matter, so it does kind of have water holding capacity, cation exchange capacity. If it is lime stabilized, many of them have lime, so when you put it out, you're getting your lime requirement. I just did this, I actually used last year's rates. This is an old biosolids analysis from Blue Plains when they were Class B. But again, the farmer, you were saying, why does the farmer do this? I mean, he gets all this value for free. Now granted, he has to go through the program, we have to get the permit. It takes a while to get that permit. There's a lot of things. And then once we have the permit, it kind of has to wait till we can get there. And again, depending on what contracts we have, it's not like calling up crop production or Southern States and saying, hey, next Thursday, can you do my farm? It's, You know, Blue Plains is a big plant, but not many plants make that kind of production. So normal plants, you might have a couple loads coming out a day. I can do 10 acres a day, maybe, depending on what I've got on any given time. So, you know, it's going to take me a while to get across his land to put down the nutrients that he needs for whatever particular crop. So, and then it rains in between, so I've got to stop. And then the next guy's waiting, and everybody. So you're kind of in a rotation, you're in a schedule. So the fact they sort of, again, we can't get to everybody all the time, so we try to rotate who can get some this year, next year. But it is a huge savings. Even if they don't need phosphorus, you're still over $100 an acre. You know, and then lime is pretty expensive, so depending on where you are. But, you know, these guys, when they plan, we plan ahead and make sure so they're not buying fertilizer. We pretty much on the Class B program, bring it in for free, spread it, incorporate it, and leave, and they're ready to plant when we leave. So there's a lot, and we write the plan if they need a plan, or we work off of the plan that they have. So, you know, soil samples are in this. You know, there's a lot of stuff that the farmers are getting to participate in it, but they've got a lot of headaches to deal with. So, you know, you've got neighbors, you've got signage, you've got permits. So it's a process. Again, Allison talked about when we come in, we've got to make sure their soil pH is at 6 before we apply, or we bring it to 6 when we apply the lime stabilized material. And then we can't get it too high. So sometimes guys have used lime stabilized year after year, and then their pHs are too high. So at that point, we can't apply lime anymore. We'll probably come in with maybe a digested product and try to bring their stuff back down, or wait till they do something else as it comes down. So this is just a couple pictures. So on the dewatered cake, like I was saying, comes in. I mean, it looks like manure consistency. You know, it's typically in the 20 to 30% solid. So that still means it's still pretty wet. You know, that's 70 to 80% moisture, but it handles and stacks pretty well. It's not like it's runny, but it's coming out in a tractor trailer. So a dump trailer is loaded with biosolids at the treatment plant. Comes out to the plant and unloads it in the field, the permitted field within the area we can apply. It's picked up with a front end loader and put in a manure spreader pulled behind a tractor. So nothing unusual that anybody would see, handled just like typical kind of manure application. This is the mine site. We've done a lot of mine reclamation in the summer, just so, obviously we try to hit the crop window. So spring, you're trying to hit corn and get that done, and then when everybody's planted, you're sort of like, well, what are we going to do now? The treatment plant's running all day, people are flushing every day. It's not like, just because the fields are planted. So we do a lot of sand and gravel reclamation. So at this point, we try to re-vegetate the organic matter on the site to get something to grow. A lot of these places, when they mine the site, they pull out all the good stuff, and then they backfill with whatever they have, and it's really not good soil. So we tend to come in and put a higher rate and get something to grow there, because they are required under their bonds to get something vegetated. So we do a lot of agricultural work. We do the reclamation, as Allison explained. That's sort of a marginal permit application, very similar to the Class B agricultural permit, just required to do a little bit different on sediment erosion and so forth. Again, we do some liquid. There's, most foods are really fading away from liquid. There's not much liquid out there anymore, just because they want to dewater it a little bit and not pay you to haul liquid. But if it comes out in liquid, typically it's coming in a tanker. It's then transferred to an application vehicle. So a lot of this is a little cleaner. It's not dumped on the field and picked up. It's literally transferred from the tanker right into an application vehicle, and then either incorporated right in, and then followed up with disking. If you have a different kind of tank, we've got same thing, tankers come in, we could do surface application right on top. So all of it depends on what you're getting, what the crop is at the farm. So all this has to be sort of coordinated with the farm operator. When are you planting, when are you cutting, when are you harvesting, when can we come in, what materials we have, what the plants are generating, then we sort of do a schedule to kind of pass along. So anyway, this is some calculations for you guys to kind of start getting a feel for what you need to figure out. So if I went today, I get an analysis, and again, there's that Blue Plains lime state before they went to Class A. They're roughly 33% solid, so they're a very dry product. That's their nitrogen ammonia content. So this is what I would look at to calculate what we have to do for an application rate. I'm going to figure out the plant available nitrogen in these biosolids. So each one, Again, the state kind of gives you numbers, but this is how we get there. So you take the analysis and you calculate the available nitrogen. Again, if you look at some of these, so like Blue Plains lime stable, that means it was treated through lime stabilization. So lime was added to the solids at the treatment plant. As you see, their nitrogen is a little lower than, you start looking at some of the anaerobic digesters. They're in the 5s and 6s. The more digested products, they're higher nitrogen. The lime tends to react with the nitrogen and volatilize some, so you tend to get a lower nitrogen. So how do we figure out what's in there? So we take the analysis, and I'll use those Blue Plains and sod runs again, but basically I kind of put the calculation under there for you. So from the previous table, you had the percent TKN, which was 4.02. So literally in the decimal fraction, you're going to multiply that by 2,000. And that's going to give you pounds per dry ton. So what is in that actual source? And I just did that for each of the nitrogen sources, the elements in the product. Same thing. Looking at the sod run digest, which was 6.03% TKN. So literally I calculate these out on a pounds per dry ton. However, think about it. What comes out in the field isn't a dry ton. It's wet. So once we've gotten it to dry ton calculation, you guys all good on that? We're going to convert it to wet tons. Because that's what comes out in the field. What comes to me in the field is in the wet form. It's not completely dried. So if you take that previous page where I had calculated the dry pounds of Blue Plains, which came out to be the 80.4, and then multiply it by the decimal of the percent solid. So the drier it is, so now that 80 is now wet. So every wet ton that comes out in that truck has 27 pounds of TKN. So typically a truck is bringing out 20 tons in a load. A legal load is around 20, 22 tons. So every wet ton that comes out in that truck has 27 pounds of Blue Plains. Sod run is actually 18, which is a little interesting because the table before, remember, it was 120 pounds a dry ton. But the fact that this is only 15% solids versus 30, on a wet ton basis, it's actually lower, if that makes sense. So these are how we figure out. So we're getting our numbers from the state. Here's the treatment plants. We're calculating our numbers for application. So how do we figure these out? So now, I just wanted to compare. So we did the Blue Plains and the sod run, but look at them against typical other manures. So, a wet ton of these against a poultry litter, they don't compete. Dairy manure, obviously, they're a lot higher. So again, just kind of looking at what you have out there, but you also have to kind of know what your sources are and what those values are, and then how do they mineralize over time. Some of them, obviously, they're all organic sources, so they break down over time. Some is available this year, a little bit more next year, and a little bit the following year. So all that gets done with biosolids just like you would do in the manure calculations. Again, so in our packages, our first package going into the state for a site, we include a nutrient management plan. And that nutrient management plan, we've taken the soil samples, we're doing just like any other nutrient management plan. We're writing the plan based on what crops are going to grow, their yields. But what we do at the end is we calculate a table of application based on the sources that we've done for those things. So we're still minusing out any residual manure that they've used, if they've got previous legumes. We're running a PSI or a PMT, or doing both now since you have to do both, depending on where their soil level falls out on their tests. All that's sent into the state. The only difference in the biosolids nutrient management plan is it's only good for 1 year, whereas your guys' plans are typically good for 3 with some minor updates. They're good for a year, or you run on them. So if I write it for this year, even though the permit's good for a 5, so I want to run, this spring in 17, I turned it in and it came out, I'm going to run this year. If he wants to do something next year or the year after, after I've run, I've got to recollect soil samples, redo the residual calculations based on the previous year's application, and update that plan before you can run again. So just sort of like any other plan. If you've done anything different in between, you update it as you go. Same thing, kind of covered that. We're covering the same exact thing in a regular plan. The only thing we're doing different is calculating those nitrogen available calculations. Same thing for phosphorus on this in each of the sources. One thing we had to do, is we have to calculate residuals just like you do on the manures, and thank goodness we're now following the nutrient management regulations and only going back 3 years. In the past, the Biosolids program made us go back 10 years of applications. So right now, we're only doing three years. So your initial one, your 2 years after. So similar to everything else, you're calculating what you've done. This is, calculating your rate. So if I need, easy math, if the farmer needs 100 pounds of nitrogen, and my pan for easy math was 25 pounds of dry ton, I'm going to apply 4 dry tons of my material to the acre. But if I calculate that into wet tons, I'm going to multiply that by the percent solids to convert that to how many wet tons of material are coming out. So, but all of our permits are in dry tons. So I know it's a little complicated, but everything is dry tons. Our metals are in dry, everything's a dry weight basis. So from an application standpoint, we convert everything to wet tons. So you're working off of what literally is coming to you in the truck. Same thing, we're doing a standard plan. Pan calculations, I'm sure, are in there, but I did an example in here just so you know. For the biosolids, we have to calculate the plant available nitrogen. So the way we do that for the very first year, look at some of those analyses, is we're going to look at the ammonia content, the volatilization factor, and again, that's based on whether we're taking a liquid and putting it on top, or if we're putting on this incorporating, or if we're putting any dewatered. So basically, your volatilization factor could be 0.5 or 1, depending on how you apply the material, what kind of material it is and how you apply it. And then the mineralization factor is depending upon sort of what we're running. That chart tells you first year. So if it's a lime stave or a digest, you're basically an aerobic digest, you're going to do 3. If it's anaerobically digest, it's a 0.2. And there's a table telling you how to calculate these. So this one is I just plugged in a firm for that Blue Plains, and that's how we got that 27 pretty much pounds per dry ton. I literally took the numbers from that first table and plugged them into the pan calculation. And so once you have that, this is sort of your Bible of what you can apply of that material to any particular farm based on their nutrient management plan. So depending on what nitrogen, assuming they're a nitrogen-based plant. Now if there's however that and they have to do phosphorus, we also calculate the phosphorus numbers, and then the plan is based on phosphorus application. But typically with our applications, we try to look at farms that really aren't in a phosphorus, aren't too high. We're trying to work off of nitrogen-based plans, because guys are looking for real fertilizer, and if they can't get enough for their crop, it's sort of go through the whole program to get half of the rate. It's not really to their benefit. So we really work with them to see where their soils are and their levels. Again, this was just another formula so you had in your notes how to calculate that. What formula, what you're using, what numbers you need, how to get to the end value for your explanation. So here's that chart again, first year. Again, if you were lime stave or aerobic, you're using that 30%, and the values are in the tables for you in there. So depending on what source you have, your nitrogen mineralizes a little bit different. And again, we're only going back 3, whereas before we used to do 10. So going back and calculating your residuals for the next application, thank goodness we're back to 3 and following regular nutrient management. So again, our plan looks just like anybody else's plan. We'll put in our previous year's biosolids if there was any manure, and we literally are writing it across, doing the same exact setup. So our plans don't really look any different than anybody else's. We're doing exactly the same thing, except for calculating the biosolids availability of nitrogen and phosphorus in their plan versus anything else. And we're taking into account if they have manures or other things on the site. Phosphorus, again, we're doing both. So depending on where their soil level falls out, just like everybody else, we're running the index, we're running the PMT. One thing to know about biosolids and phosphorus is a lot of the treatment plants, like I talked about, with their advanced treatment, and actually for odor control, they tend to add a lot of chemicals from iron and aluminum to remove phosphorus, as well as for odor, they use ferric and something. So a lot of the phosphorus that's in the biosolids is pretty tightly bound. It's not really that readily available. So if you run an available phosphorus test on the biosolids, it's really not, it might be high, it might show a high number, but the phosphorus is already tied up with iron and aluminum. And if they lime stabilize, you're then also getting the calcium tie up. Now that's a little bit more available over time. But when you compare the phosphorus in biosolids to some of the animal manures, it's not nearly as available as the phosphorus in some of the manures. So where to go? Obviously, Allison's group is great. If you need any information, they can give you historical applications. A lot of times, if you go to the farmer, again, when the contractor leaves, we leave the farmer with a summary of what he received. So when we leave, we're giving him a packet that says, you got 109 pounds of nitrogen, 75 pounds of P, 2 pounds of potash, this much lime. He gets a summary. So when you come out and he wants you to write his plan and he can't find it, he has it. He just usually doesn't, I never got that. Well, everybody leaves with a summary. They just may not necessarily put it in their package. So if you need it, maybe you can call the contractor if he knows who he used. Obviously, Allison's group has historical application rates. The contractors turn in reports to the state of where they've applied, how much was applied, on a regular basis. So going back to try to create that history, there is an avenue to get it. And I think that's it. Any specific questions?